Hey Wheaton North, Mr. Frittner here, and we are going to talk about single replacement reactions. So single replacement reactions are when one element gets replaced by another element in a compound, and that's sort of illustrated in this picture on the screen. You can see that at the start, B and C, which represent elements, are together as a compound at first. They're buddied up, they're nice and happy together, and then A sort of swoops in and steals C from B. And then at the end, A has replaced B, so now A and C are the couple. They are the compound together, and B is the single element on its own. So that's what's happening in these single replacement reactions, and that's what we're going to talk about throughout this video. So the one rule that we need to keep in mind is that metals are always going to replace metals in single replacement reactions, and nonmetals are always going to replace nonmetals in single replacement reactions. And this basically is another way of saying that likes replace likes. So if the single element in the reaction is a metal, then it's going to replace the metal in the compound. If the single element in the reaction is a nonmetal, it's going to replace the nonmetal. So again, likes replace likes. It's always going to replace the same kind of element. Now I'm just going to show you an example of one of these single replacement reactions. So this is going to be copper reacting with silver nitrate. And basically, we'll kind of see it get set up. The single element in this case is copper. You can see the wire in there. Now they're pouring in silver nitrate into it. And now the reaction doesn't happen instantaneously, so this video is actually sped up. You can see it happening very quickly here. And the copper is replacing the silver in that compound. So you're left with the silver by itself, and then the copper nitrate as the compound. So that's just a quick example of this happening in real life, copper and silver nitrate reacting to have that copper replace the silver, leaving you with silver and copper nitrate. So again, it just replaces that single element. So here's another example. We have zinc and two HCl molecules. And our first question is, what is zinc trying to replace? Well, we know we already said that like replaces like. So zinc itself is a metal, and it wants to replace another metal. Now in this situation, our two choices are H and Cl, hydrogen and chlorine, which both are technically nonmetals. But H, hydrogen, is on the left side of the periodic table. It is going to sort of act like a metal in this case because it's going to make a positive ion with the negative ion of the chlorine. So the zinc's going to try to replace our hydrogen in this case. Now, the second question that we need to always ask ourselves is that element reactive enough to replace the other element? And the way that we're going to find that is with what we call the activity series. So right now, what I want you all to do is take out your periodic table, the one that you should either have printed out or have saved somewhere, and either on the back of the physical copy or if you scroll down on your digital copy, you should be able to find a spot that says activity series, and it looks just like this. It has a list of metals and it has a list of nonmetals. Just like that. And basically, the rule that we're going to go with here is that elements to the left on the activity series are more reactive than elements that are farther to the right. What this means is that elements can replace any element after them, because in a single replacement reaction, we want the more reactive elements to replace the less reactive elements. That's the only way that the reaction is actually going to take place, is if an element is being replaced by something that's more reactive than it. If it's less reactive, then the reaction won't take place. It won't replace anything. Everything will just stay as is. So in our example here, we have zinc trying to replace hydrogen. So you look on your activity series, we're looking under the metals, and you find the two that we have. So here's zinc, and Zn, here's zinc, and then keep looking, and here is our H2, our hydrogen. Zinc is farther to the left than hydrogen, which means that it's more reactive and it will replace it. So this reaction can happen and the zinc will replace the hydrogen. So that's what you're going to do each of these times in each of these reactions, is just see, can this happen? Is this element reactive enough to make the reaction happen? So just to say all that again, the activity series is how you find this. So you look on your activity series, you look either under metals or nonmetals, depending on what type of element is trying to be replaced here. If you're looking at metals, you look at this long list of metals. If you're looking at nonmetals replacing each other, then you look at the shorter list of nonmetals. And elements on the left are more reactive than elements on the right. So elements farther on the left can replace any element after them, because any element after it is the list of elements that are less reactive. All right, so let's take a look at another example and see if we can figure it out. So you can see at the bottom we have barium and calcium nitride. Those are our two things being added together. We have barium as the single element, calcium nitride as the compound, and our job is to see if this reaction can take place. So first, we always ask ourselves, what is barium trying to replace? What is this single barium trying to replace in the compound? And since barium itself is a metal, it's going to try to replace the metal, which is calcium. So barium is trying to replace calcium, and now we just need to look at our activity series and see which is more reactive. So let's find them. All right, here's barium, Ba, and if you go farther to the right, you find calcium, Ca. So barium is farther to the left, meaning it can replace calcium. This reaction is possible, so you would write down the final compounds. So calcium is by itself, because that's the one that's replaced, and then barium replaces the calcium in that compound. So instead of calcium nitride, we finish with barium nitride. All right, let's try another one of these. So now we have iodine and magnesium bromide. So what is iodine trying to replace? Iodine, that's our nonmetal, so it's trying to replace the bromide part of it, bromine. So we're going to look at the nonmetals this time. Find the two of them. We'll start with iodine. It's the last one here, the I, and then the bromide, that is our Br. So that's farther to the left than the iodine. The iodine is less reactive, so it's not going to be reactive enough to make this reaction take place. Nothing's going to happen. So in this case, you would be able to just write that there is no reaction, because no reaction would take place. And then finally, we'll do one more example. Bromine plus sodium iodide. All right, so what is bromine trying to replace? It's the nonmetal, so it's going to try to replace that iodide in the compound. So again, let's look at our activity series, nonmetals, because that's what we're dealing with. Here's the bromine, here's the iodide. So bromine is farther to the left, it's more reactive. This reaction can take place. So you simply switch the two, because bromine is trying to replace the iodide. And since the iodine is no longer in the reaction, you can just write it as iodine instead of iodide. And then since the bromine is in the equation now, or is in the compound now, you can call it bromide. So it's iodine plus sodium bromide. And that's all we're doing with this, is just checking if the reaction is possible. If it is, then write the new element and new compound that we have. Thank you for sticking with me during this video. If you have any questions, you can ask me or your chemistry teacher. Thank you.